I think uh, we have only one participant. So we have 2 points to discuss. One is, uh, yes, have you decided any topic? For example, the for the research purpose or for the learning purpose, uh, which population will take, how you will take sample, etc. Can you tell me that?
Some past days
You
for
are not audible. Speak loudly.
right now I'm audible, sir.
Yeah, now is your audible.
Sorry, sir, I missed last class, so I don't know what you discussed in the last class.
Okay.
But if you are asking for the any research topic, now currently
Hmm.
I am thinking about work on NFHS data, National Family Samples.
Yes.
Want to do some research or some any new finding in that data.
Mhm. So
130.
that will be the something like review of literature, but you can critically evaluate it, and or you can compare with your own area. You may
Right,
study
sir.
the whole country, but when you study about the country, you are situated in which place?
In Maharashtra, sir. I am from Maharashtra.
Okay, yeah, any particular district?
Akola.
Poland. So that will be very interesting. What is the data of the maybe a nation,
Yeah.
Gujarat, Maharashtra, or some other
Yeah.
Karnataka like that, and then
Yeah.
within Maharashtra, various districts, and in that Akola. So if
Right.
you and why it's like so. So basically, if you study that kind of thing, and then you take another sample from Akola itself,
Right,
and
sir.
for the coverage, you require only 19 individuals to select. Only 19, 19 for
Only
coverage.
90.
Telling, yeah.
Okay. I'm
Any,
also studying QGS software for presenting data on a map.
mm-hmm.
So FHS data quite helpful for that.
Yes, yes.
Right, sir. Currently, I'm working on that.
So you
Want to work
belong to
on
which
that. Not
specialty?
currently working on that. Want to work on such research.
You belong to which specialty?
I'm from statistics background, sir.
Acha, yeah, that will be wonderful. And
Yes, sir.
people who are background of statistics should try to connect with people like us doctors, no, in community medicine department. Say
Yeah, yeah,
around
sir.
40, 50 community medicine department, we have added TC data, UHTC data like that. So
Right, sir.
if you do the meta-analysis, that will be very useful to the doctors. I'm not working with any medical college right now. I just got retired on 4th June, just a month back. Anyway, so today will be anything from Mansa Faki. You have any topic in mind? So as the design goes, I will be talking about the. Hi, you please, Mansa Faki, you can tell about your topic if you decided some topic. Any topic you decided for the purpose of research? Okay, so let me go ahead. Awareness or comparison. I was thinking about an awareness or yes, okay. You can do the comparison and the awareness study. So the main thing is to understand in the research, etc. Minimum sample size required regarding yes, okay. Okay. So for study and awareness, etc., what is the minimum sample size required? That is very, very important. Suppose you want to study about awareness or comparison regarding reproductive technology, assisted reproductive technology among the doctors, among the community, like that. So, how much sample you would require? Suppose you want to, your population is Gujarat or your population is Maharashtra, something like that. In that case, how much sample is required is very, very important, and that will depend on how how close you would like to have the your judgment to the truth. So if you want to be very sure about almost same, then you require the whole population. But you say that 1% here or there, a bit larger sample, the smaller sample, 2% here or there, plus minus, still lower sample, like that. So now, let me talk something about if we have a small sample size, what kind of analysis we'll be able to do that I'll be taking today. This, so Crystal Wallace edge test we'll be talking about. And in this, we have a multiple samples, but the number in each sample is very low. So what we are doing in this Crystal Wallace test, that will be, this you may not understand right now, but the H we want to find out. We'll come back again to this H. Let us see with the example first. So let's say we have four groups, right? In your case, it could be a four word, and then each word, the you can say that the number of days that four patients stayed, or number of improvement in terms of percentage or reduction in the illness or reduction of the pain, etc. In this case, we have four groups of students, and they taught with the different methods, and they scored this mark. In group number one, 65, 87, 73, 79 marks, group P, like this. So the question is, this difference in group V1, 2, 3, and 4 is significantly different or not? That is the question. So in such case, we'll be using Kruskal-Wallis test. So now, there are total 16 ranks are there, right? So we start with the lowest. See, let's say the 89, 59 is the lowest, then comes 62, then comes 65. So we give them a rank, and total 16 ranks are given. It is possible that there can be a same marks for two individuals. At that time also, we give a different rank. So this is the first thing is ranking. This TI is total. TI means T1, T2, T3, T4, like this. 1, 2, 3, 4. And null hypothesis says that the distribution of the score are the same amongst all the four groups, while alternative hypothesis says that distribution differs in location. All the four types are different. Now this test statistics H equal to this 12 is a constant figure irrespective of whether you have taken 5 groups, 6 groups, or in each there are 7 cells or 8 cells, but this 12 remains the same. Now here the n total number of observation is 16, and this is n plus 1, 16 plus is 17. And now this is a summation Ti square. That means this 31, 35, 15, and 55. Square of all those things are kept over here, divided by Ni. That is how many groups are there. Total there are 4 groups. And minus 13, again, 3 is also constant. This 3 is constant each formula. You can see that. You can see over the original formula with which we started, irrespective of number of groups and number of cells in each group, this formula remains same. No? So the design is equal to, right? We say that randomized design is there. We are comparing two population, three, four population, five population. If there are two population, we could have use the t-test. And if a number is large, but here the groups are more, number is small, so we are going for Kruskal-Wallis test. In case of AP info, you will be using means test. So I repeat. So first we are taking the rank, right? Second thing, we are doing making a total. So total you are making of ranks, not the original marks. You remember this. This 65, 87, 70, 70, we are not making total of that. We are making total of rank 3, 13, 6, 9. This is one kind of statistical method by which if you have a large numbers like 94 and 14 marks like that, so you are trying to homogenize by giving a rank. That's why this is Kruskal-Wallis rank test. And then answer is 8.96. H is equal to 8.96. Now, how do we read this? I think all of you should go through the Z table, T table, chi-square table like this, because table is a very important. Today I ask you a question in which you will require Z table to give answer. So, various tables you should try to read. Now here, because it is 8.96, we'll be looking at alpha level 0.05. Usually we say that the 95%, right, is the confidence interval. Can n be an odd number? Yes. It could be, n could be 5, 6, it is possible. 7, 9, nothing, no problem. It could be. And it is not that all the cells should be of only 4. Some cell may be 5, some cell may be 6. There is no problem in that. Right? Now, in this case, the degree of freedom, 4 minus 1, is equal to, so there are 4 groups. So we have written degree of freedom is equal to 3. And the H table, right? So basically, based on that, it says that H is more than 7.81. So there is a significant difference in the marks. And we say that there is a different test score. Somebody must have taught much better. If you look at the why it is like that, why it is more and why not less. So that depends on this formula. This formula they have prepared after so many the experiment, and then they have found out this. This 8.96 or 7.91, 7.81, just like Z, we are making a 2. Similarly, different statistical the figures they are getting out of the experimentation. So in Kruskal-Wallis test, if you want to apply, you can easily do this. But fortunately, you have a computer, you have a direct interpretation, and you need to apply means test in AP Info. And if you look at the inference in AP-info, Kruskal Wallis test is automatically calculated. So if you have any question, I can answer that.
Hello, sir. I
So
have one small
yeah,
question.
yeah, please.
In rejection region, there are the right tail chi-square test for alpha and degrees of freedom. We calculate the our z calculated value of z. Na?
Hmm.
So here we using a normal distribution table, or there is any different table for
Chi-square table,
chi-square test.
chi-square table they use. See, they if you look at the chi-square value, so if you look at the degree of freedom one, it is 3.84 something like that. If you look at the chi-square value at degree of freedom three, it will be 7.8. So they are using chi-square value. And the H statistics they calculated in such a way so that ultimately they can use this test. So you need to refer that chi-square table. I think on one day, maybe around 10, 15 minutes, we should be looking exclusively as a random number table, chi-square table, Z table, key table, etc. They half an hour for the tables I should be keeping. Some of they may not be knowing. Any other question? And right side tail and left tail, the one should understand that when the figure is likely to be more, only on one side, only more. There is no possibility of less, right? In a inverted U-shaped curve, standard normal curve, you can see the left and right both are there. So we never know it whether it is increasing or decreasing. We use both the side. But when you are clear that it is only increasing, at that time we can use one tail t-test. So uh, any other question? Another example where edge test can be used. Okay, let is very good. If we prepare examples, that will be very good. Let me talk about the doctors, the profession. I would like to talk about the wards. There are four wards, or let's say there are seven wards. There is no problem in keeping seven wards. And each ward, let's say we have around seven patient, one ward, other ward, eight patients, then seven patients, six patients like this. Because if we have a 30 patients, 40 patients in each group, then ANOVA, F test will be there. But in such a small sample, seven, six, seven, like this. And for each patient, we say that expenditure by that patient, right, on discharge. Or you can take the number of days patient has to stay in the ward. Or you can take that the, uh, let's say hemoglobin level or the happiness score of each patient or recovery score or reduction in the pain score. So you have a groups. It could be a, let's say medical college. If you have, there are various, the you have a subgroups in for the purpose of the small group discussion. In one group there are seven, other group there are eight, or four students are there, and then we can look about the pulse rate. Right? This is also possible. So in Kruskal voice test, we have a small sample size, we have multiple groups. The data is measurement type of data where you can find out the mean, and this is the use of edge test. Any other question?
No, sir.
So yeah. So let us move to another test. This is one of my teacher, Dr. Dilaka Sharma, right? Man-Whitney U test and Wilcoxon sign rank test. Now, here the groups we want to compare. And here also we are comparing two groups, but here look at very, very small data, right? 3, 2, 4, 1, 2, 1, and other group also this much. Very small data is there. And we have two groups. Now, what will happen? Let's go back. Samples are randomly selected from two independent population and representative of the population. Very small sample. And it requires two set of data. They need not be paired, nor need they normally distributed. Or need there be equal numbers in each set. These are not required. And here you are using non-parametric tests because of a small sample size and they are not normally distributed. And here what we are doing, see, in this case, if it is a t-test, what we would have a bit larger number, right? But here we have a very small number like this. Right? You can say that the number of days, suppose in this case, two wards, and you want to compare number of days, or you have the two faculty groups. One is in the anatomy department, other is the physiology department, and then they leave in 1 month. How much leave they are taking? Such thing can also be there. Now here, the, the most important thing is ranking. And ranking, you should know that it should start from the minimum towards the maximum. So first is number one. Another one is the number two, like this. The second is number three. Whether it is on this side or that side, you go on applying the number. So total, there are 6 plus 7, 13 figure are there. It could be 13, 15, 17, not a problem. Now, harmonize ranks where the same value occurs more than once. Suppose we have 1 twice. So each one will have value would be 1.5, 1.5. Let us see how it looks. I will just wait for you to grasp the thing, right? Here you can say that probably it is coming in the way. Yeah. So everybody understood there are two data set available. On one side there are 7, another side is a 6. The second thing we are doing, we are giving the rank 1, 2, 3, 30. And third thing, what we are doing, you just look at over here, 1 and another 1. So the average of 1 and 2 is 1.5. So 1.5 and 1.5 is written over here. Similarly, if you look at the 4, 4 comes 4 times. So there is a summation of 10, 9, 8, and 7. Total divided by 4, that is 8.5. So if you have questions somewhere over here, I can stay back. Yes, I will move for next slide. Any questions so far? Harmonizing ranks. So next thing is, now here, we are adding up ranks of each column. We are not adding the total values. We are adding the ranks from each column. And that is Rx and Ry. And the total numbers, right? If you make a plus of this total, Rx and Ry, you can check whether it's true or not. 13 into 40 divided by 2, it will be equal to that. Now here, just like H and Z, we are calculating Ux and Uy. Out of this, whichever is small, that will be keeping. And there is another way of converting U value into Z score. Now, once we move further, you will come to know what is NX, NY, NX like this, right? Z is equal to, we are converting smaller u and into a Z square. I already shared this file with you. We'll look at this file twice so that you will understand. Now here, look at this data. This is already the data which we have seen. Here the Rx, right? This is X, this is Y. So if you make a total of this, it will be 24. If you make a total of this is 67. So you can see this. This is this Y making total 24. This is X making total 67. And total Rx plus Ry is equal to 91. And now if you look at the N, total N is 13. 13 into 40 divided by 2 is 91. That means you are going on well. You have done scoring perfect. Now finding Ux and Uy. So this is 6 into 7. Now this, you are coming, you look at this formula here. Nx, Ny, number in each cell, right? This is Nx, Ny. Ux is equal to. So based on this, they have calculated over here, right? And the answer is 3, answer is 39. I'll just wait for few seconds. If you have any questions, if you have not understood. When you look at your home, have this formula on this side, on one side, and keep this formula other side. This is how it is calculated. This 6 nx, nx plus 1, like this. Right? Any question? So lowest value is 3. And so we keep this 3 over here in U, 3. N1, N2, that is the 6 into 7, 42 divided by 2 is 21. 21 keeps over here, right? And then the square root of this, if you calculate this is 6, 7, the 6, 7 plus 1, like this, right? So initially it is 7. 7 into 6 is 42. Then 7 plus 6 plus 1. So 40. And then divide with 12. So overall, the answer is 18 by 7, 2.57. Now Z is more than 2. So this, we can say that the difference between these two original sets, this data and this data, is significantly different from each other. Even it is a very small data, we can say that the first data set is a little bit higher value compared to the second data set, right? So I hope you will be able to grasp this. Now, in this case, now we are going for another test. And usually for the patients, before and after comparison, in a small data set, this is very, very easy and important because sometimes the pain goes up, sometimes pain goes down. In this case of hemoglobin, for example, goes up, goes down, or pulse goes up, pulse goes down. So weight gain there, weight can be less also. So plus and minus both sign is applicable in this kind of data. And it's like a parity test before and after comparison. So this is where we are going to use Wilcoxon signed rank test. Sign means negative sign or positive sign that we are going to understand. So the Wilcoxon sign rank test is the non-parametric test equivalent to the dependent t-test. That which we have seen previously was like independent t-test, right? And this is like a dependent t-test, pair t-test. It is used when we wish to compare two sets of scores that come from the same participant and the number is very small. Samples are randomly selected and representative of the population. Two groups should be matched and the data is ordinal. And the W plus and W minus. Out of this, we are going to take whatever the minimum is there that we are going to calculate. So W plus is sum of ranks for the positive differences. W minus is sum of ranks for the negative differences. Because pain can increase, pain can decrease. When you have both the side, at that time you are using this test. Now let us look at the The test has 6. W is given by the sum of all the positive values in the sign rank test. Negative is given by the sum of all the negative values. In this example is W33 and this is minus 12, the is equal to 12. So 12 we are going to take it, right? Now, how do they calculate? Now, rating before therapy, rating after therapy. So the patient number, the number one was having a 5 rating. After 4 weeks, 2 rating. So pain reduced. So they said plus, plus, plus. Now it was minus 4 and this is a 7. So it's a minus. 9 minus 6 is was it 3? This is nil, no sign because same. So first thing is clear how you sign 5 and 2, 8 and 4, this plus. 4 and then the pain increased to 7, so it is a minus. Now, when you do talk about the difference, then you apply these differences, apply with the minus plus sign, right? And then when you go for absolute value, it is 3, 4, 2, 3, like this. And now when you have the absolute value with you, give a scoring to that. This is the smallest one. Then is the 2. That is the 3, like this. And then you are again taking a mean. For example, 3 comes twice. So 5 and 6. 5 and 6. We are taking average 5.5. Once you have taken this rank and then you apply again this sign. You apply this sign. And then this is the final rank of sign. So I just allow you some time to grasp. First, rating before therapy and rating after 4 weeks therapy. Probably all of you have understood. Is the patient's response. Now, sign plus means 5 minus 2 is 3. So it is a plus. Now, what you need to understand is before you give a rank, take an absolute value and to absolute value, give a rank 1, 2, 3, 4 like this. Once you've given the rank, you should take an average of that rank. For example, the let's say 1, 4. 4 comes twice. So 1, 4 is given rank 8, another 4 is given rank 9. So the average of this is 8.5. So it is 8.5 here and 8.5 here. Once you give a rank, harmonize the rank, then you apply this plus or minus sign. So this is a rank of sign that we have. Now we'll take a positive total and total of the negative. So we have taken that positive is 33, negative is 12. So we'll be considering W is equal to 12. And then we'll be looking at the table value. So now let's go to the table value. Now, watch it for some time. This is a point zero 0.01, this is point zero 0.02, this is a point zero 0.05, right? So look at the n. In our case, n is the 10. At that time, the critical value is 8. And as critical value is decreasing, more and more significance is there. Now, in our case, let us see what was the critical value. Critical value was 12, right? For a two-tailed p-value of 0.05. Now, here we can say that the up to 8, if it is a 5, 3 like this, it is highly significant. But in our case, W is 12. That means more than this 8, more than 8. So it comes on this side. That means it is more than 0.05. So we say that it is not significant. So look at this. So decreasing pain, increasing pain, there is no significant difference before and after the therapy. So whatever the therapy was going on, acupuncture was not significant in 10 participants. This we can say. So this is the beauty of the test. Even in the small number, we could work out. So any question on this? There's another example also, right? Before instruction, after instruction, they have calculated. So we have seen three type of tests, and also I think uh, let's have some question answer. Any question on this? Then I can stay back with this file. So let me finish this, right? Now the forum is open for question answer. And if you have found thought of some topic, we can discuss on that. If there is nothing, then we'll repeat the AP info. We'll also look at just scan through the protocols because the files are given to you. Dr. Somia and other people, any question? So 5 minutes for the AP info. Launch the AP info. I hope everybody of you have installed and have started using it. We had not seen on that day probably StatCalc. Now this StatCalc is very good for you to find out the sample size. Now in this case, this Poisson distribution is a very, when the event is rare, we are using that Poisson distribution. Uh, Let me start with some the question to understand that, right? Uh, I would like to share for Poisson distribution. Now, suppose I have a 10,000 population, and other population I have 1 lakh population. Let us keep it 10 lakh population. Here it is 10,000, it is 10 lakh population. I want to find out the whether these people are receiving adequate government services or not. And I decided that I will sample size N1 and here sample size N2. Now, my the question is, uh, I'll be writing somewhere in the chat box. You tell me you would like to have N1 should be more than N2 or N1 should be equal to N2 or N2 should be more than N1. Look at the data carefully and then tell me. I have three options. Which one should be there? Here the population is 10,000. Let's say this is group A1, this is group A2. And for study purpose, I want to select the sample size to find out whether the people are getting adequate services or not. Now, give me the answer. Whether it could be equal, whether N1 should be more. Okay, someone says that both should be equal. Anyone else? On A2, we have 10 lakh population. So try to understand that was. Anyone? Any comment? So it is like this, which we can have the almost same sample size, provided we'll be able to find out the representative sample from that population. Instead of this 10 lakh, if there is a, let's say, 10 CR, 10 crore, and if it is not possible to take the representative sample, then we may have to increase. Otherwise, sample size does not depend on the population size. Now, in this case, another example that in this case, there's a 50% people are taking the services. And in this case, now let me take for only 10,000 only, right? And here, people are taking approximately based on the data, 40% uh, taking adequate services. Now, if it is a 50% and it is a 40%, now tell me, N1 should be more or N2 should be more or should be equal. Give me that answer. This is a very, very important. Here we are using standard error of proportion. A1 should be more. N2 should be more. Let me have a third also. A3 and 3. Here it is 10%. Now tell me, see, actually, when you have, let's say, equal number, you have a red balls and green balls, both 50-50, and you want to find out the difference from the population where it is taken, then it will be extremely difficult to differentiate. But if it is 10% and 90%, then the probability is easily calculated. And if that population, if you want to find out, it is not that difficult because differentiation power is more. Now 90% and 10%. If this is the dissimilarity in the sample, based on that you can talk of the population. But in population is the chances of 50-50%, then differentiation power is reduced and that's why you need to have a more sample size. And that's why we say that standard error is equal to root PQ by N. Root PQ upon standard error is equal to. In other way, if you make a square of it and then you find out N, in this case, N is equal to 2AC is equal to L. And that's why we say that PQ 2 PQ upon L square. L square. Let me write down this way. Square of L. L is equal to SE. This way. If you look at the n sample size, n will depend on multiplication of P and Q. So if you take 50 into 50, 2500. But if you take 90 into 10, it is 900. So the sample size required will be more if there is a 50%, 50%, right? But in case of 10% and 90%, sample size required will be less. Now, tell me this A4, where the it is something like 0.1%. So sample size for this N4 will be less or more. Tell me that. N1 should be more than N2, N2 should be more than N3, right? What about N4? So in case of N4, because event is much less, it will not follow the standard normal distribution curve. It will follow the Poisson distribution. So suppose here the multiplication score will be 2500. It will be 2400. Here it will be 900. Here it will be much less, much less. But that will not determine your this sample size, because to find out 0.1%, to find that event, we need a larger population. So here sample size will increase. This is something about Poisson distribution. And so when we calculate that kind of rare event, at that time sample size will be more. Now, if you look at that, if you are doing a population survey, for example, right, then you are writing population size. You keep something like this. This is your population size. Then expected frequency. If it is a 50%, then the sample size, usually we take 95%. It is 383. Usually this comes, we talk about 400. 400 sample size usually we say is required. Right? But if you want to go for a higher precision, then naturally you will have higher sample size. If you acceptable margin of level, if you want to reduce that, then automatically sample size required is much more. You say that it is 10%, then sample size required less. So acceptable margin of error, plus minus 2, plus minus 3, whatever you want to do, accordingly it will be there. Now the word design effect, this you should keep in mind when, let's say there is a population of 1 lakh population. This is very, very useful design effect. In 1 lakh population, you are directly taking 100 individuals by simple random sampling. 100 people out of 1 lakh you are directly taking, then this sample size is okay. But in 1 lakh population, you are dividing them into 5,000, and from each 5,000, you are taking a sample to make it 100. Then because you have done stratification, this is known as design effect. And you have done stratification once, so you need to keep a design effect 2 over here. Now, you are doing stratification, right? And then further, you are dividing them. First, it was according to the region, and now according to the religion. So, region and then religion. If you are doing this twice, then the design effect will be 3. So, more the complicated you take, more sample size you need to take. And you can see this changes, you can see in the, when you want to do the population survey, you will see the design effect too, automatic sample size increases. So this is how you can take use of StatCalc, and you will have the AP info manual. See, I'm just knowing a little bit statistics, maybe around 5-10%, 5-10% AP info, etc. But young people among you, if you look at the AP info manual, you will see a lot of things over here. And if you have ready-made available data with you, for example, outcome and exposure, and if you write something over here, if it is like this, if you put only this four data, automatically you will get odds ratio and the relative risk ratio, everything, including cascaders, everything you will get if you have ready-made data. You can keep this four sets. Now, this is something happening at one center, but at other center, the data is different. So it is like this. This is second data. So if you can go on adding the strata over here of different centers, and at the end you will get summary results over here. Summary result you will be getting, combining everything together. This is something like meta-analysis. And it is collating around 4, 5 centers or 10 centers data, where you are not having the raw data with you. You have only the result. You can keep it the result over here and then can do the analysis. So this is something about StatCalc which you can use it. And you have also the create forms, then enter data. This is a little bit advanced, but not that difficult. But usually we are using classes. So before I end the class over here, if you have any question, you can come out with the question.
So, what is the
Yeah.
design effect and how it affects the study?
See, in case of, let's say this is a design effect, such a wonderful concept that these the random sample, the definition of random sample is each individual within the population has an equal chance of being selected. Now, when we say the statistics population means all the observation, right, under the study, all possible observation. It is not that human being, but if heights are taken of 10,000 human being, 10,000 height is the population. And height of one person is an individual. So each individual within a population has an equal chance of being selected. That is a representative sample. Now, out of 10,000 population, you are selecting 100 individuals by simple random table. That means everyone is having equal chance of being selected. But when you are dividing them into a strata like that, see, for example, see 10,000 population, 1,000 each. And from 1,000, when you are applying the random number table, so what happens? The chances of each individual being selected is not the same as it was directly selected from the whole population. And because to make it representative, we need to take double the sample size. Because of the stratification, the randomization gets affected. And to remove that affection, we are doubling the sample size. If the random, if there is a further the stratification in age group, then we will be taking design effect 3. That means 3 times the sample size. If original is 400, you should go for 1200. So that is the design effect. For example, the whole India you want to take, and from 140 crore population, you want to randomly select 1 lakh, right? Sample size. That's okay. But you want to now divide into the states, various states you are dividing, then you require 2 lakh the sample size. But Now you want to, each state you are dividing into the district, then you require three times the sample size. But if you divide the India directly into the district, 600 districts, then you need to take 1 lakh into 2. That is 2 lakh. So, so whenever it is possible to take a direct, then the sample size requires less. That is the point in design effect. Any other question? So just 2 minutes. Meanwhile, you can ask the question. Projects, sample projects, select the project file. Within project, there will be so many tables, right? And you're selecting a file table. You can define the variables, you can assign the value, you can record the things. Age, for example, if there's 1, 2, 3, 4, you can directly record the age in a group of 5. All this is possible with AP info. And then your frequency tables and means will be taking the means of age for against the illness. And suppose if your data is much less, then here you have a crystal Wallace test for 2 groups, and this H is given over here, P value is also given here, right? So all the non-parametric tests, whether to accept non-parametric or parametric, that depends on us, that what is the size of the group, etc. And even if you don't want to do that, then look at this. This Barless test for inequality of population variances. Right? It shows the whether the population, right? It says that variances are not homogeneous and ANOVA may not be appropriate. If a small p value will be suggesting that, but if the p value is here, it is more. So you can apply the ANOVA. So you need not go for non-parametric test. See, this is what AP info gives you. Whether the distribution is normal distribution or not. If this 0.72, if it comes to be 0.001, then you cannot apply ANOVA and you need to look at this non-parametric test. So it's a big ocean. I hope you will love this AP info. I close my session over here. Thank you very much. I like to interact with yes much more because you are asking a question, I'm enjoying the answering and probably learning more from you. Thank you all.
Thank you, sir. Thank you so much.